Bismillahirrahmanirrahim. Today we will start the next session of our chapter, that is distributed database integration. So we were talking about schema matching. Schema matching involves two important aspects. One is called the schema heterogeneity, which basically include the structural heterogeneity and the semantic heterogeneity. When I say the structural heterogeneity, it means that we are talking about a construct. So whatever the construct we have, for example, whatever the definitions we have in the given relation is basically represented in terms of structural heterogeneity when we talk about types. So whenever we are matching the schemas, one of the aspect which is there is the type conflict. So we might have various types uh, for various attributes. So those conflicts had to be resolved while we are matching. Number two, the dependency conflict. The dependency relationship among various attributes might be different in various schemas when we're talking about the local conceptual schemas. Then there might be a key conflict. Yes, it is quite possible that when we are matching the schemas, so it is quite possible that in one schema, the key of the given relation is different. For example, employees are represented with a different key, and in the other schema, the employees are represented with a different key. Similarly, let's suppose the projects are represented with a separate key in one relation and in a different from a different key in a other relation. So we might have the key conflicts, not necessarily that we have the same key attributes in all the local conceptual schemas. And the last is behavioral conflicts. The definitions itself, how we define those various attributes and what they actually represent is also is a kind of behavioral conflict which we have to resolve whenever we talk about schema matching. So all of these are called structural heterogeneity. And of course, whenever we talk about distributed environment, we are talking about most of the time we are talking about heterogeneous environment in which we might have various tables, we might have various ways of representing the attributes, we might have different keys, and we might have various types. The second component which is very important whenever we go for the schema heterogeneity is the semantic heterogeneity, because okay, it is easier to resolve the types, it is easier to resolve the keys, it is easier to resolve the behavioral conflicts, but it is difficult to manage the semantic heterogeneity. That is why we say it is more important and harder to deal with. That is why it is difficult to deal with such elements. Maybe sometimes we have confusions in terms of synonyms. So sometimes we are using various names, but they are different. They are synonyms. Sometimes we are using homonyms, hyponyms, so on and so forth. So we have to determine what they are representing. Are they the same or they are the different? So we have to come out with the actual meaning of that particular element. Similarly, we have, when we talk about semantic heterogeneity, we have to deal with various kind of ontologies. When I say ontologies, it means the representation. So we might have various representation. Let's suppose I am matching two various schemas running at two various sites, and they are having a different ontology of representing those various elements within the schema. So when we have very different ontologies, then we have to determine some mechanism how we can match the attributes, how we can match the actual values of those attributes, so on and so forth. And of course, the last thing which is very important is imprecise wording. So sometimes we represent something in full, sometime we represent something with let's suppose with some initials maybe, Sometimes we write the complete information, sometimes we don't write the complete information. For example, we are representing an employee with the complete name along with the middle name, and sometimes we are only using the first name or the first name and the last name. Or even we are, if when we are describing, for example, the various items, so somewhere we write some keywords, so we have imprecision in defining those values. So that cause difficulty while we are matching two values. Let's suppose if you are representing one value in one table, and another value in another table, and when you match these two values, and obviously you have to decide whether they are both representing the same thing or both representing the different thing. Other complications include the insufficient schema and instance information. Sometimes we don't have the complete information of the schema. Okay. And when we have incomplete information or insufficient information of the schema or the instance, maybe. So in that case, it is difficult to match, because then we have to use some techniques and to decide whether they are the same or not. Sometimes we'll have problems when we don't have the complete documentation with ourselves, because while we're talking about various local conceptual schemas, so you need to have a schema definition which represent each and everything, and we can see the model, and we can then determine the exact meaning of it. So it will be helpful for us to match these various elements or the values. And the third thing, which is also important, is the subjectivity of the matching. So we are not just dealing with the objectivity, we are dealing with the subjectivity of the matching as well. Sometimes two terms looks to be common, but they are not. So we need to see that what is the subjectivity. Only the values and only sometimes only the representation itself does not matter. So what it subjects to, that is also important. What is the representation? So issue that affect schema matching. Now, when we go for the schema matching approach, so we might have one thing that we might have is called the schema versus instance matching. Or either you go for schema to schema matching. Let's suppose you took a schema with employee, department, projects, and you have another schema over there in the other LCS, and you just try to match those schemas directly. Or you pick an instance. For instance, you just pick an instance that these employees are working in this project. You just pick that instance and you try to match those instances on both sides to see whether they are representing the same thing or not. Or even you can go for the element versus the structural level, or the values which are representing, you match those, or you want to match the structure. For example, when I say structure, it means you match the attributes, number of attributes, you match the attribute types to attribute types, so on and so forth. Or you look for those values and match them. And last important thing here, which is relevant with the schema matching, is called the matching cardinality. The matching cardinality refers to the number of counts you have. Whenever you match, for example, the employees from one end to the other, or you want to match the instance from one relation to the other, then it is called the cardinality. So sometimes we are also interested to know that how many times that particular instance matched with the schema in the other relation. So if you combine all those approaches, you will get this sort of a tree, and this tree represents the various methods and approaches for schema matching. Uh, you can see the approaches over here, and you will find out the various techniques which might be used to do this schema matching task. So the tree is basically divided into two approaches. First of all, one is called the schema based, and second one is called the instance based. So either you go for schema matching, or either you go for the instance matching. If you go for instance matching, for instance, then you have to go for the element level, because you are matching the instance. For example, you're talking about employees working in a specific project, so you are looking for an element and you try to match those elements, whether those employees are there, are the same employees over there, so those both employees representing the same thing, or both the employees representing the same project. So instance based matching, you will go for the element level approach. And for the element level approach, you might have three approaches, which can be linguistic, which can be constraint based, which can be learning based. Okay, number one, if you go for linguistic approach is just like the NLP approach. And because it is linguistic, so we just go for the matching of, let's suppose, the characters, matching of the characters, matching of the string, and so on and so forth. So we'll try to match these two values. For example, one item is represented in one warehouse. For example, is a bolt. So we'll try to look into the other schema whether that bolt is there or not. We just try to match these two things together in terms of linguistic approach, and this gives us the exact matching, whether it is 80% similar or 90% similar or might be 100% similar. This will help us to know that whether they are representing the same thing or not. That is the first approach we have. The second approach is basically based on conditioning. Uh, and that conditioning and reasoning basically takes us to this approach that is called constraint based. So, what we do, we make the conditions. If these conditions meet, it means they are representing the same thing. So, the constraints there define actually whether those elements match or not. For example, if we are defining for example, the items in a warehouse, so well, what we do is we try to see the conditions, we try to see the constraints. What are the constraints? Maybe in terms of price, in terms of weight, in terms of make, so on and so forth, and whatever you like. And let's suppose if you are going to match the projects. So what you will do is that you will decide certain constraints, and then you will see that whether both in both the situations the elements representing the same constraints or justify or fulfill the same constraints. If this happens, it means they are the same. And the third approach here is called the learning based approach. The learning based approach is basically based on the machine learning approach. And in a machine learning approach, you'll go for the classification. And here what you will do is try to come out with the learning model, and you will try to make those classes. uh, and obviously for that you need to have the training data, and on the basis of that training data you may apply various machine learning approaches. Might be you go for the neural network approach, or various other approaches we have. The learning based approaches help us to classify those elements. If the elements belong to the same class, it means they are representing the same thing. So these three approaches can be used to match those elements. And when you come toward the schema based approach, in schema you have again two approaches. Either again you go for the either you go for the element level exact value, and either you go for the structural level. So here in the schema based approach, either you go for the linguistic approach or the constraint based approach. Here you will not use the learning based approach because you are matching the schema, and you are matching the schema with respect to an element. So here normally we use the linguistic approach or the constraint based approach. And if you go for the structural level, we always use this constraint based approach. Why? Because you cannot directly match it, because it based on certain conditions, certain criteria. So the constraint based reasoning is much better way to match the structural level. Basically, it you can say it to match the structure. The constraint-based approach is is suitable, and you have these various approaches with yourself, and according to that you apply it. Let's suppose if you go for the uh, linguistic schema matching approach, so which is used at the element level as well, and that linguistic approach can be used for the instance matching as well. So linguistic schema matching approach, number one, we use to represent the element names and other textual information. And obviously, it is being represented in terms of textual descriptions, in terms of alphabets, numbers, text, and so on and so forth, and various annotations. And for that purpose, you might use external resources as well. For example, uh, let's suppose if we are using any software from the web, you might have various such softwares which are available, which can match your text with all the text which is available on the web. For example, Turnitin is also used as an application that use that approach, but that is used for the web. Here we're not talking about the web, but for example, if we are interested in the linguistic schema matching approaches, we can integrate the external sources just as thesauri or various corpus which are available universally. So we can integrate those various corpus and thesauri for matching those textual information, because if you are going for the linguistic matching approach. So in that approach, what we'll try to do is we'll try to match, and what is the representation? That representation will be the schema one dot element one is approximately equal to schema two dot element two comma p comma s, where element one in the schema one is similar to element two in the schema two if the predicate p holds with the similarity value of s. And that is, the similarity value means how much percent they are the same. For example, if you submit an assignment to me and I will check that assignment from the web using a Turnitin software to know that how much similar content is there or from where you have taken those resources. So that also give me the similarity index. That might be that might be 80, that might be 90, that might be 70. If it is in the case of the assignments, then we'll call it the plagiarized assignments. So please don't do this. So here, but we are talking about the textual matching. So here, when the similarity is, let's suppose if it is on the scale of 0 to 1, so if that similarity value is nearer to 1, it means that these two elements are similar. Obviously, with respect to the given predicate, that predicate is the condition, the given scenario, the given condition. The schema level deal with the names of schema elements, of course. The schema level obviously is defined with terms of, with reference to their schema elements. And there we have to handle cases such as synonyms, hypernyms, data types, and similarities. So we want to see two elements and want to see whether they are similar or not, or they are representing the same thing or not, or they are the same but they have different meaning. That is quite possible. Or they have the same data types, or they have some sort of similarity. Instance level focus on the information retrieval techniques. Example, so when we go for the instance level, normally we go for word frequencies and key terms. How many times that word is being represented, or the same word is represented, or the terms, whatever we define those terms, and we want to see at the instance level whether they are repeating or not. So how many times they have been repeating. And obviously we deduce the similarities from these. So once we know that whether the same term is being used many times. So we'll try to deduce the similarity from these values, and then we can decide whether they match or not. Linguistic matchers uh, use a set of linguistic rules. Basic rules can be handcrafted or maybe discovered from outside sources. Example, WorldNet. You can you can make your own rules as well. When I say handcrafted, it means you might define your own rule for linguistic matching. For example, if you want to know that the first four words should be similar, if the first four words are similar, alphabets are similar, then you think it's similar. And or of course, if you want to see only the word bolt comes into that particular item, whether it is at the end or it is in the beginning, so you have defined the rule that whether bolt is there or not. So this is something which is handcrafted. So you might have your own rules, and or either you can discover it from other sources which can help you in finding out those rules as well. So there are so predicate p and similarity value s. So it is handcrafted. It means you have specified. For example, I just gave you example of a bolt. So you have identified that wherever the bolt is, it means they are representing the same thing. So it is handcrafted. So it is specified as well. I have specified it that these are the four alphabets B, O, and L, T. They come together. So in that manner. So wherever they come in the beginning or in the end, that represent the same thing. And second thing is discovered, which is not specified, but when you apply the linguistic matching approach, those are discovered, maybe computed or specified by an expert after discovery. For example, I don't have the idea. So what I did is I basically executed various combinations, and I just tried to find out how many times these combinations are coming in the given text or when I match these values. So I have discovered something which is not specified as in the first case. So either it can be specified or it can be discovered. Both things are there. For example, now you have you want to apply the uppercase and the lowercase. This you want to apply this thing on the upper cases or the lower cases. For example, when you go for the matching, you say that the uppercase names and the lowercase names are representing the same thing. So you just want to see whether these case names or the lowercase names or the mix of uppercase and lowercase are there. So you think that it is approximately equal. Of course, they are equal according to your matching approach. So might be items are defined in lowercase in one schema, and the items are defined in the uppercase in another schema, and you will just try to match them. So how you will represent this? That SCI element 1, so it representing the uppercase names, and SCI SC2 elements 2, it's a lowercase name, so approximately equal, and your predicate says is true. So it's true with the value of 1. So if it is true with the value of 1, the predicate says it's true with the value of 1, it means they are representing the same thing. Or the uppercase name is approximately equal to capitalized names. According to your predicate, it should be true, and with the value 1, it means they are representing the same thing. Similarly, if you go at the end, you can see that db1 dot assignment. db1 is representing one schema, and you're talking about a table that is called assignment. So db1 dot assignment, and in another schema db2 which you want to match, there you have another table that is called works in. So it says that db.assignment approximately equal to db2.works in is true. But here it is with the probability of zero point 0.8, the value of zero point 0.8, it means they are approximately equal with 80% probability, or you can say the value of zero point 0.8. So it is quite similar. So it means you can match these two values because they look similar. So in one schema, the same thing is represented with works in, and in another schema, the same thing is represented with assignment. But although when you match them, you find out the 80% values are similar, it means they are representing the same thing. So that is how these linguistic match approaches works. Okay, there are other kinds of similarities and you can say commonalities are there, and that can be discovered automatically. And how we can do it? This is possible with the help of calculating the n-grams using an n-gram approach. Uh, Affixes. What is affixes? Affixes means the common prefixes and suffixes between two elements named string. That is quite possible. We use sometimes various things, sometimes prefix or suffix with a certain thing. For example, you are representing an item. So if you are representing an item, you might write something before that item name or maybe something after that item name. That is basically your prefix and suffix, and it might be different in various schemas. Obviously, that creates problem when we are matching these terms. Sometimes we are representing even in the names as well. Sometimes we want to represent someone like doctor, someone like might be Mr. or Miss or Mrs. And at the end we might write something. Let's suppose Dr. Nadeem PhD. So it means I have a prefix of doctor as well and a suffix of PhD. I added this. So, so that representation, and on the other hand, I only have Dr. Nadeem Mahmood. So it means we have at one place we have a prefix and a suffix, which has a different representation, and in the other schema, it might have a different representation. So we go for n-gram approach, which really is a useful tool over here, comparing how many substrings of length n are common between the two name strings. So what we'll try to find out by using an n-grams approach is to find out the substring, uh, which means that a substring common among the two name strings. So for that purpose, we go for another approach that is called added distance. That is another approach, added distance, number of characters modifications. What operation you might apply to have the same thing. For example, at one place my name is written as Dr. Nadeem PhD, and on the other side my name is written as Dr. Nadeem Mahmood. So here, if you want to make the two names similar, then you have to apply the added distance approach. You have to apply certain modifications. Either you will delete the PhD from there, and you will also delete the Mahmood from there. So then the both names will become similar. So it means you have applied certain things. Even you can apply additions as well. You want to make these two values the same, Dr. Nadeem Mahmood, Dr. Nadeem Mahmood. So in that way, you have to delete the PhD and then you have to add MAH, MOOD in the element of the schema 1, and then they become the similar. That is why these modifications are normally represented in terms of additions, deletions, and insertion, which basically converts one string to another. The third approach is Soundex code, which is phonetic similarity. Phonetic similarity is normally used when you want to represent the same thing, in the same manner. There you use the Soundex code. That is the that basically related to the pronunciation of certain thing, because when you represent one thing, sometimes you represent it differently and on the other side you represent the same thing differently in terms of phonetics. So if you want to make it similar, then you go for the sound export. In that case, the n-gram and edit distance approach is more likely to use instead of the sound export. Also look at data types. So data type similarity may suggest a stronger relationship than the computed similarity using these methods, or to differentiate between multiple strings with same values. So data type similarity may suggest stronger relationship. This is just a hint, or you can say it is an heuristic, which really helps you to find out whether they match or not. So if they're representing the same data type, then the computed similarity using these methods, or to differentiate between multiple string with the same value. So sometimes your heuristics might work. For example, n-gram approach is basically, for example, if you just want to see how it works, and here n can be replaced by any number. It might be 2, it might be 3, it might be 5. It all depends upon the similarity which you want to apply. So 3 gram of string responsibility are the following, where we have, let's suppose, these three strings which are being represented here, over here. And let's suppose if we want to apply the 3 gram of string RESP, or RES and ESP. So let's suppose if we apply the 3 gram similarity over here on this particular string, that is RESP, and you can see here only there are two which where we can see RES and ESP, which basically we can see which are possible. So here you can say that there are two possibilities, and total possibilities are 12. So that is 2 divided by 12, that gives you 0.17. So that is 0.717, or you can say is the similarity which might exist when you apply the 3 gram approach. And that is how it can be used whenever we can use it in any schema matching. Added distance, you can see here. Again, we consider the string responsibility and RESP. To convert responsibility into RESP, what we have to do? We have to delete these characters. And to convert, if you want to convert RESP to the responsibility, we have to add characters. So the number of edit operation required in both the cases are 10. So that is how many total characters we have. We have total characters 14. So we are adding 10. So 10 upon 14. So 1 minus 10 upon 14 is equal to 0.29. So if we apply the added distance, you can compute those values, which represents your case. So how much distance, added distance, is there if you want to change it. So if there is more added distance, it means that they are not very much similar. That there's a less added distance, it means they are quite similar. For example, if you want to convert this responsibility to into response, so there you have to delete 1, 2, 3, 4, 5, 6, and add 1. So that will be 7 upon 14. So this gives you the higher value. So on and so forth. Constraint based methods. When you talk about constraint based methods, okay, you have to use with various ranges. For example, you can check the ranges, and then you can see, let's suppose if you want to have the matching of, let's say, the time allocated in the projects, those employees who have been allocated time to those projects. So then you apply certain constraints based on those ranges. and that time might be which employee can give in a project, that might cannot exceed 30 hours, or it cannot be less than 10 hours. So you have a range, so you can make a range and then you compare it, the various ranges, and then you might know that they are similar or not. Similarly, if those values are representing the marks of the students, so you might have various ranges, and then you can see whether these ranges are same or not. So here what you did is you come out with the constraints, various, uh, and that is defined by yourself. So RESP and responsibility you have used with n-gram approach. If they come from the same domain, they may increase their similarity value. Yes, of course. If they are from the same domain, the similarity values increase. If similarity values increase, it means they are similar. So if the similarity value is near to 1, it means they are similar. If similarity value is near to 0, it means they are not similar. So ENO, employee number, in relational model, you can say, is might be represented as a worker dot number and project dot number in ER. So in a relational model, in a relation, it is represented as worker dot number, and in the project, it is represented in the ER, it is represented as project dot number. So they are representing, both are representing number, but in a different manner. In an ER, it is when I say ER, it means identity relationship model, and when I say relation, it means in the schema, in the relation schema representation. So ENO and worker dot number may have type integer, while product number may have product dot number, project dot number, sorry, may have the string. Yes, this is quite possible. You can represent the same manner because it's an employee number. It might be represented as a number. It might be represented as a string. So if they're representing the same thing, whether they are representing the various types, it means they are representing the same thing. So that will help you to decide that they are either same or not. So you apply those conditions and then check whether they meet those conditions or not. If two schema elements are structurally similar, then there is a higher likelihood that they represent the same concept. Quite true, because if you are matching two elements in the structure and you think they are similar, then it means that they are representing the same thing. Now, but let's suppose the number in one table and the other number in the other table, in the project table, although they are representing to this, with different data types, but they are representing the same thing. They are representing the employees. So their similarity value is higher. So it means they are representing the same concept. Similarly, for example, if you want to match the specifications of the items, if those specifications of the items are representing they are more similar into various schemas which you are going to match, so it means there are likelihood that they are representing the same thing. Might be in one table it is represented as specifications, and in the other table it might be represented as details. In one table might be it is represented with a string value, or might be used with any other type. So it means they are representing the same thing. So structural similarities, when we talk about structural similarities, so one thing which is there is called the same properties, like attributes. So when we match them, we say, okay, this attribute is same with this attribute representing the same thing. So these are called the attribute properties if they are same. Second is called neighborhood similarity. When you map one attribute to another, it means you're talking about same properties among those two attributes. But sometimes you need to determine the neighborhood similarity. Okay, if this is A is matching with B, B is matching with C, C is matching with D and A, D is matching with B and A, B is matching with A. So it means now you are looking for neighborhood similarity. And for that purpose, you need to build a graph or a network, and you connect those various neighbors together to know what similarity they might have. So by analyzing the network or by analyzing the graph, you will be able to know which of these two have the similarity. The set of nodes that can be reached within a particular path length from a node are the neighbors of that node. So that is the basic definition of the neighbors in terms of a graph. Uh, if you have studied the graph theory, the set of nodes that can be reached. For example, if there is a node E, there is a node A. If that E is reached through A by various nodes, then you can say they are connected. So if two nodes have similar set of neighbors, then they are likely to represent the same concept. This is the approach we use in the networks. For example, if there are three nodes A, B, and C, so C is also a neighbor of A and C is also a neighbor of B, then it means that A and B most likely are representing the same concept. So that is one way of finding out the similarity using the neighborhood model. And for that purpose, we need to plot the graph. So I hope that you understood the concept of the constraint matching approach and as well as the linguistic matching approach. The third approach is called the learning-based approach. And when I say the learning-based approach, so it means that we're talking about using the machine learning techniques. And machine learning techniques are quite often used to determine the possible classes we have. And that is why it is represented as a classification problem. And when I say classification problem, basically it means that we have to classify the concepts. So we have to, for various schemas, into classes according to the similarity we have. Those that fall into the same class represent the similar concept. That is one way by which we can do it. And for that purpose, we might have various methods. For example, support vector machines. You might use the uh, support vector machine. Sometimes we can use the ANN approach, or we might use other approaches as well. Nearest neighborhood technique, like we have discussed earlier on. For that, we can make also classes. Similarity is defined according to features of data instance. So what we do is that we classify the problem in terms of the concept, and then we see, okay, whether it falls into this class or not. So if it falls into this class, for example, you have defined the class of the assignment or the work defined. So you just try you define those concepts and then you observe that whether those elements or instances they fall into it or not. If they fall into it, it means they follow the learning based. They are same and they belong to a similar class. So in that helps you to match those elements or even the match that schema. So similarity is defined according to the features of data instances. So obviously it is defined in terms of data. For example, if you want to match employee, so you have to define the features of employee. If you want to match the project, or you want to match the work assigned, or you want to match the departments, or you want to match any other instance, then you have to have those features with yourself, and then you'll see that whether when you give it the trained data to your model, how it classify, okay, and so more values you add into it, so the learning model will improve. So that is a good thing about a learning model. So the learning model also get also whenever you have new instances, so data set will increase, the train set will increase, and you can also validate it based on certain values you have. And that is why we say this, the classification is learned from a training set. So it all depends on how you have developed that training set. So if you have a good training set, and if you have good values, means in numbers, then you might have good results in by using machine learning techniques. So learning-based schemas matching is normally work in this manner, that we have the given, for example, domain and the element, which we want to see whether they are the same or not. And we will give it to the learner, and learner uses the probabilistic knowledge, because we do not have a certain knowledge over here. So we need to have a probabilistic reasoning. So that based on that probabilistic knowledge, the classifier classifies it, okay, and it gives you the classification prediction. Uh, Sometime it shows that they are 80% similar, so that falls into this class. They are 85 similar similar, so they fall into this class, or they are not similar. So you might have values less than 50%, so it means they are not similar. So in that manner, that the learning classifier works, and that is the combined approaches we have. When we talk about combined approaches, so it means we can might have various approaches which can be used at the same time. So use multiple matchers. Each matcher focus on one area. For example, name or the type or any other thing. Meta matcher integrate these into a prediction. So obviously, when you go for meta matcher, it means that when you come about all the information regarding various matches, then you'll be able to have that prediction. So integration may be simple. So obviously then you can integrate these two things. Take average of the similarity values or more complex, or you can see the Fagan work. The Fagan also described the way how we can integrate two components or two elements when we have the similarity values with ourselves. And that is the uh, schema integration. Use the correspondence to create the GCS. And obviously, what is the integration process? Integration process integrates all those schemas or instances or elements. And when they are integrated, actually what you do is that you come about the definition of GCS. So mainly a manual process, although rules can help. So we have either use a ladder approach or a balanced approach. These are two are normally used with binary. And if you are using an array, so you can go for one shot, and or you go for iterative approach, and then you have the integration process, because you have to integrate these two things together. So if you go stepwise, on the left hand side, you can see in the picture A that if you go the stepwise, so this is the first step, this is the second step, this is the third step. If you go for the pure binary, so it means every node has two nodes. So when these two nodes will be resolved, then these two nodes will be resolved, then these two nodes will be resolved, so on and so forth. So either you go for the stepwise or the binary approach, or the one pass or the iterative. So if you have the iterative, then it means you go for from here to here, then from here to this, from this, and then you can come out again, and then you have all those instances, or all those these elements will be matched, and you have the complete representation. So iterative means it is the same process is repeating every time, and that is one pass. So at one time you have the one pass which is available, by which you can integrate it to a single node. So schema mapping data from each local source, which is called LCS, to the target GCS, that's called global conceptual schema, while preserving the semantic consistency as defined in both sources and targets. So normally we have in warehouses, we have the actual translation. In data integration system, when we talk about data integration system, discover mappings that can be used in the query processing phase. So obviously those mapping will help us while you resolve those queries, because the queries will execute in the same manner uh, and will reach out to the specific instance which you want to retrieve. And that is used for mapping creation and mapping maintenance. So here you can say the mapping creation. So that is your source LCS. That is S is equal to SI. That can be 1, 2, 3, 4, and so on and so forth. And that is your target GCS. You might combine two LCS and then the third and then the fourth. So that will be added. Set of value Corresponding discovered during the schema matching phase will be represented as V is equal to VI. Produce a set of queries that when executed will create GCS data instances from the source data. So when you generate such queries, that will create the GCS instances, because those queries then will be representing all those instances or the elements which are defined in various local conceptual schemas. So if you go for the combined query, basically it will create the GCS definition. So we are looking for each TK at a query QK that is defined on a possibly proper subset of the relation S, such that when executed will generate data from TI from the source relation. So this is called the mapping creation, and that same thing is represented over here with in the form of an algorithm, which basically tells you the number of steps you have, how you can build those that mapping. Because once you have that integration done, then you can map it. And once you map it, then it means that you are able to execute those queries and to see how it will be executed globally. Thank you so much, and I hope you will understand the chapter. Please go through with the chapter in detail and come out with your queries as soon as possible. Thank you so much.